Hello, my name is Raina D. Jute, and this is the problem-solving video for Module 15. I completed 5 required LeetCode challenges, and in this video I'll walk through each one, showing the completed solution and explaining the reasoning behind my approach. I'm going to keep most of this at a high level, focused on the thinking, and go deeper on a couple of the ideas that I found interesting. Where it connects to my actual project code blogs, I'll point that out, because a few of these ideas showed up in my real work too this week. So the first problem is reverse linked list. Here is the solution. So a linked list is just a chain of items where each one points to the next. The task is to flip that chain so it runs backwards. At a high level, my approach is to walk through the list one item at a time, and as I go, flip each pointer to face the other way. The one thing that you have to be careful about, and this is the whole trick, is that before you flip a pointer, you have to save where you were going next, otherwise you'll lose the rest of the list. So I keep track of the previous item, the current item, then I save the next one, then I flip them, and then I step forward. When I reach the end, the previous pointer is sitting on the new front of the list. The second problem is number of islands. So as you can see, this is the solution. So you're given a grid of land and water, and you count how many separate islands there are. The high-level idea is simple. So we scan the grid, and every time we hit a piece of land that we haven't seen before, that's a new island. So we add it to the count. The important part is what happens next. I then explore outward from that spot in all 4 directions and mark every connected piece of land as visited, so I don't count the same island again. I'm going to go a little bit deeper here because this idea of marking things as visited is something I'll come back to in the next problem, and it's a pattern I actually ran into in my project. So the reason I mark land as visited is to avoid processing the same thing twice. In my code blogs work, I had the same kind of thinking when I was handling comments. I need a reliable way to know which item I was dealing with and not double handle it. So this keep track of what you've already touched idea is more general than just this puzzle. The third problem is clone graph. And this is the one that I found the most interesting. So a graph is a set of nodes connected to each other, as we can see in the photo right here. The task is to make a complete separate copy, every node and every connection, without the copy secretly sharing anything with the original. The challenge is that graphs can loop back on themselves, so if you naively follow the connections, you can end up kind of going in circles forever. So my solution uses exactly that visited idea from the previous problem. I keep a record of every node that I've already copied. When I reach a node, if I've already made a copy of it, I just use that copy instead of making a new one. That's what stops that infinite loop circling. This is the one that tied the most directly into my project, so I'll go a little bit deeper. So in React, which is the front end of code blogs, there's a really important rule. You don't change data directly, you make a copy and change the copy. The whole reason is the same as this problem. You don't want your new version secretly sharing references with the old one, because then changing one accidentally changes the other. Working through clone graph actually made that React rule kind of click for me, because it's the same concept, a true independent copy, not a shared reference. So this wasn't just an abstract puzzle, it explained something that I relied on in my real code base. The fourth problem is binary tree level order traversal. Say that 5 times fast. A tree is a structure that branches out from a single top node, and we've seen this in a couple other LeetCode problems before. The task is to read it level by level, top to bottom, grouping the values by which row they're on. My high-level approach is to handle one full level at a time, looking at everything on the current level, record those values together, and then collect all their children to become the next level. So instead of diving deep down one branch, we sweep across each level completely before moving down. Quick project tie-in here is that trees are everywhere in web development. The page itself is a tree of elements, and React builds the interface as a tree of components. So getting comfortable with how you walk through a tree level by level is directly relevant to how most of our applications, especially using React, are actually structured. Then the fifth problem is permutations. The goal here is to generate every possible ordering of a set of numbers. The high-level idea is to build each arrangement one slot at a time. Pick something for the first slot, then from what's left, pick the next, and so on and so forth until you've used everything. This is another one that I'll go a bit deeper on because the technique behind it is worth explaining. It's called backtracking. So the idea is that you make a choice, explore everywhere that this choice leads, and then, and this is the key part, you undo the choice and then you try the next option. In my code, you can see that pattern. I add a number, then I explore, and then we remove it again before trying the next one. That do it, explore, then undo it loop is what lets me cover every possibility without missing or repeating any of them. This was the first time that I've explored backtracking, and it actually made a whole lot of sense to me. And the way I think about it now is it's just being systematic about trying every option and cleaning up after yourself each time. So at a high level, those are all 5 of my LeetCode problems today. The biggest thing I took from doing these was learning to spot the underlying pattern rather than treating each problem as totally new. And in last week's LeetCode problem solving video, I found a lot of connections to my real world project that helped me think through those problems. So it's definitely something I want to use going forward, because being able to tie something that feels like a new concept into something that I've already known and had experience with makes both of those things make more sense to me. Whether that's tracking what you've already visited, making true independent copies, or systematically trying every option. And a couple of these, especially the copying idea from Clone Graph, genuinely deepened how I understand the framework that I'm using in my actual project. So that's all I have for this video. Thank you for watching, and I will see you on the next one.